Each of these options has its own advantages and disadvantages, especially when it comes to network design and balancing costs with performance. VPC peering allows direct communication between two VPCs, but it can become complex as the number of VPCs increases. Transit Gateway simplifies this by acting as a central hub for multiple VPCs, making it easier to manage connections. PrivateLink, on the other hand, is great for securely accessing services without exposing them to the public internet. Think of it like choosing a route for a road trip. You can take a direct path, a scenic route, or a highway that connects multiple destinations. Each choice affects your travel time and experience. In summary, understanding these options helps you make informed decisions for effective communication between your applications. Let's focus on VPC peering. This is essentially a simple point-to-point connection between two virtual private clouds, or VPCs. When you set up VPC peering, the route tables for both VPCs are updated to allow traffic to flow between them. Importantly, this traffic uses private IP addresses, which means it remains secure and isolated from the public internet. Think of VPC peering like a private road connecting two neighborhoods. Just as cars can travel back and forth without going on two busy public streets, data can move between the two VPCs without exposing it to outside traffic. In summary, VPC peering is a straightforward way to connect two VPCs securely, allowing for efficient communication while keeping the data private. In a typical peering setup, if VPC A is connected to VPC B, and VPC B is connected to VPC C, VPC A cannot directly access VPC C. This limitation can be a challenge when you want to enable communication across multiple networks. However, the Transit Gateway addresses this issue by implementing a hub-and-spoke model. In this model, multiple VPCs and on-premise networks connect through a centralized route table. This allows for transitive routing, meaning that VPC can now communicate with VPC through VPC without any direct connection. Think of it like a central post office in a city. If you want to send a letter from one neighborhood to another, you can drop it off at the post office, which then routes it to the correct neighborhood, even if there's no direct mail route between them. In summary, the Transit Gateway simplifies network management and enables seamless communication between multiple VPCs and on-premise networks. To understand this better, think of PrivateLink as a private tunnel that connects your house directly to a friend's house without going out onto the busy street. This tunnel ensures that your connection is secure and private, allowing you to access services without exposing them to the public internet. It's also important to note the differences in connectivity types. PrivateLink provides service-level connectivity, while Transit Gateway offers network-level connectivity, and peering is more about simple point-to-point connections. In summary, PrivateLink is all about secure, private access to specific services, making it a valuable tool in cloud architecture. First, we will set up peering between the dev and prod VPCs. This means that these two environments will be able to communicate directly with each other, allowing for easier collaboration and resource sharing. Next, we will establish a transit gateway for centralized routing among all three VPCs. This will help manage the traffic flow efficiently, ensuring that data can move seamlessly between them. Finally, we will implement PrivateLink within the Shared Services VPC to create a secure connection to the RDS endpoint. This setup allows our applications to access the database without exposing it to the public internet. Think of it like setting up different rooms in a house, where each room has its own purpose but can still communicate through a central hallway. In summary, We will create 3 VPCs, set up peering, a transit gateway, and PrivateLink to enhance our network's functionality and security. First, let's understand how different components interact. When we talk about direct communication between development and production environments, we refer to a method called peering. This allows two VPCs to communicate directly without going through the internet. Then, we have the transit gateway, which facilitates transitive communication among all VPCs connected to it. This means that if VPC A is connected to the transit gateway, and VPC B is also connected, they can communicate with each other through the gateway. Additionally, services like Lambda or RDS can use PrivateLink for secure access, ensuring that sensitive data remains protected. It's important to validate these connections. We can use tools like the VPC Reachability Analyzer and ping tests to check if everything is working as expected. A common mistake candidates make is assuming that peering allows for transitive routing, which it does not. They also sometimes confuse the use cases for transit gateway and PrivateLink. In summary, understanding these components and their interactions is crucial for effective cloud architecture. When setting up your network, it's crucial to understand the pros and cons of each connectivity option available to you. This means visualizing your architecture and testing your routing and security settings to ensure everything works as intended. For instance, if you're using VPC peering, it allows for direct point-to-point connections between virtual private clouds. On the other hand, a transit gateway provides a hub-and-spoke model, which can simplify your network management. Additionally, PrivateLink offers a secure way to connect services at the service level. In summary, always ensure your route tables and security groups are correctly configured, and take the time to understand the different connectivity options to avoid any traffic issues. For instance, if you're building a video streaming application, you might need to prioritize low latency and high bandwidth connectivity to ensure smooth playback. On the other hand, if you're working on a data processing application, you might focus on reliable and secure connections to handle sensitive information. So, remember to always align your connectivity choices with the needs of your use case. If you found this video helpful, please give it a like, subscribe for more content, and let me know in the comments which advanced OS topic you'd like to explore next.